equation of kinematics by calculus method. So to derive first equation, V is equals to U plus AT. As we know that A is equals to dV divided by dt. By the cross multiplication, we can write dV is equals to A dt. Let at t is equals to 0, velocity is u, and at t is equals to t, velocity is v. Now integrate the above equation for the appropriate limits. So we can write integration u to v dv is equals to integration 0 to t att. Now as we solve the integration for dv, there is v and the limits are u to v. A will be the constant and the integration for dt will be t, and the limits from 0 to t. And next step we will solve the limit. So there is v minus u from upper limit. In place of v, we substitute v, then minus. In place of v, we will substitute u. So we get v minus u is equals to a in bracket t minus 0. Now further simplify it. So we get v minus u is equals to at. It can be written as v is equals to u plus at, which is the first equation of motion by calculus method. Now second equation by the calculus method. So as we know that velocity is equals to dx divided by dt. It can be written as dx is equals to v dt. Let at t is equals to 0, position is equals to x naught, and at t is equals to t, position equal to x. Now integrate the above equation for the appropriate limits. So we write x naught to x dx, here 0 to t v dt. Now in next step we will substitute the value of v from first equation. So there is x naught to x dx 0 to t, in place of v u plus at then dt. Now integration of dx will be x, limits from x naught to x is equals to 0 to t u dt plus 0 to t at dt. Now in next step it is x minus x naught is equals to u t 0 to t plus a t square divided by t 0 to t. Now simplify x minus x naught u t minus 0 plus 1 by 2 a t square minus square of 0. In place of x minus x naught, we will write s. So there is s is equals to ut plus half at square. This is second equation of motion by the calculus method. Now third equation of motion by calculus method. So as we know, v is equals to dx divided by dt. It can be written as dv divided by dt after multiplying and dividing by dv into dx divided by dt. Now in next step, in place of dv divided by dt, we will write a. Remaining will be dx divided by dt. By the cross multiplication, we can write a dx is equals to v dv. Let at t is equals to 0, position x naught and velocity u after time t means at t is equals to t, position x and velocity v. Now integrate the above equation for the appropriate limit. So we write x naught to x a dx is equals to u to v v d. A constant, integration of dx will be x, so limits x naught to x. Here integration of v with respect to dv, v square divided by 2, and the limits are from u to v. Now further simplify. It is a in bracket x minus x naught is equals to 1 by 2 in bracket v square minus u square. In place of x minus x naught, we will substitute s. So as is equals to 1 by 2 in bracket v square minus u square. By the cross multiplication, we get v square minus u square is equals to 2as, or v square is equals to u square plus 2as. This is third equation by the calculus method. Now fourth equation of motion by calculus method is displacement in nth seconds by calculus method. As we know that v is equals to dx divided by dt. In next step, we can write dx is equals to v dt. Let at t is equals to n minus 1, position is at x n minus 1, and at t is equals to n, position is at xn. So we integrate the above equation as integration x n minus 1 xn dx is equals to integration n minus 1 n v dt. As we solve this integration, will be x, then limits x n minus 1 xn. Here we will substitute the value of v from first equation. So we get integration n minus 1 to n u plus at dt. Next step, this is xn minus xn minus 1. Here x integration n minus 1 n u dt plus integration n minus 1 and et dt. X n minus x n minus 1, this is represented by displacement in nth second denoted by s and here u t n minus 1 n plus a t square divided by 2 n minus 1 n. Now further simplify. This is u in bracket n minus 1 plus a by 2 in bracket n square minus n minus 1 whole square as n is equals to this is u plus a by 2 in bracket n square minus n square minus n plus 11. As n is equals to u plus a by 2. These both the values will cancel out. There is only 2n minus 1, which is displacement in nth second by the calculus method. So these are all four equations of the kinematics by calculus method.